Yeah, so if we're trying to prove S blob is a group, we need to prove 4 things, okay? One is closure, and we need to prove it is closed, and then we need to prove it is associative, okay? And then we need to prove there is a unique identity element, and then we need to find inverse for every single element, okay? So for prove closure, yeah, Mayuran, could you please tell us what do we do for closure? Yeah, what's given, what's required to prove? Hey, Mayuran? Uh, yeah, Aaron, could you please tell us, yeah, for closure, what do we need to do? Given what and then required to prove what? If we're trying to show S blob is a group. Yeah.
So you like say A is an element of S,
Mm.
X is an element of S. Therefore, for all A blob X equals X blob A is an element of S.
No, I'm just trying to say this in general, okay? So even without, so for this box, for this entire, so if we don't know anything about, okay? So we're just trying to show S blob is a group. You don't know anything else. What is the given, what's required to prove? Assume this is the only thing we know so far. Like in general. Yeah, so for closure, you're just taking any two elements and then you're trying to prove once they operate together, it's also within the group, right? So we just take, yeah, so it's given P is an element of S and Q is also element of S. Okay, those are just two random elements in S. And then we're required to prove, yeah, so any two random element in S, when we operate them together, it's also it's also element of S. That's what we're trying to show for every single closure. Okay. Yeah, so for every single closure, you always start with this. Yeah. So P is element of S, Q is element of S, and we're just trying to show when we operate them together whether it is in S or not. Yeah. So because P is element of S, so we said if A is element of S, then A blob X equals X blob A. So if P is element of S, we know P blob S, so P blob X equals to X blob P, okay, for all X in G. And then we also know Q is element in S. Yeah. So Dylan, what does Q is the element of S tell us?
Q blob X equals X blob P for X in G.
Yeah, for all X in G. Okay, and then if we're trying to show P blob Q is element of S, Aaron, what do we require to show? Like, what should we show? If we can prove P blob Q, yeah, so say here, if you want to, yeah, so this question is very clear. If you want to show anything is an element of S, if you want to show anything is element of S, you need to show anything operate with X would equals X operate with itself, right?
Right.
So if we can show A, yeah, you go.
So would you do P operated with Q operated with X
Mm.
equal to X operated with P operated with Q?
Yeah, perfect. So if we can show P operated with Q operated with X equals to X operated with P operated with Q, if you can show this, and then we can conclude P blob Q is also element of S, therefore it is closed. Is the idea clear?
Yep.
Okay. Yeah, so now we just need to go from those two lines and then eventually reach this line. Okay. Yeah, so go from those two lines, eventually reach this line. So I'm just going to, so this is required to prove, right? I'll just start with left hand side and then eventually go to right hand side, okay? So left hand side equals to P blob Q blob X. Yeah, I'm just going to keep going, and then hopefully I'll get to X blob P blob Q. Okay, so first of all, this equals to P blob Q blob X. Yeah, Dylan, which law did I use?
Associative.
Yeah, associative. Okay. Associative. And then can we use associative?
No, aren't you trying to prove it's a set?
You can.
Saying that it's a set.
You can, because there's a big given here. So given G blob is a group. Yeah, so given G blob is a group, we can write down 4 things. Okay. Yeah, Dylan, could you please tell us, given G blob is a group, what are the 4 properties we already have?
Its closed satisfies the associative law. There's a unique identity element.
Yeah.
And
Every element has its own inverse. Yeah, perfect. So because G is a group, so we already know blob must be associative, right? If blob is not associative, then G won't be a group. Yeah, so from here we already know G is associative. So of course we can we can directly use associative. And then for proving associative, all you need to say is just because G is a group, therefore blob is associative, therefore S is associative. Okay, S blob is also associative because operation will stay the same. Just like for addition, doesn't matter you do addition, real under addition, or complex number under addition, or integers under addition. Doesn't matter what is said. Okay, associative has nothing to do with the set. Associative only to do with your operation. Okay, associative and commutative only to do with the operation. Yeah, so associative or commutative, you just need to look at the operation. You don't need to look at which set it is. Yeah, so for associative, because G is a group, so this blob is already associative because that's something we know at the beginning. We don't really need to prove it is associative. You just directly state that's associative. Okay. Yeah, so Q blob X, okay, Q blob X equals to X blob Q. Yeah, Hasini, could you please tell us why Q blob X equals X blob Q?
Because of community.
And it's not because of commutative law. Dylan, do you know why Q? It's not also it's
substituted exception.
yeah, it's just a substitution. Okay, this is a substitution because we already know it here. Q blob X equals X blob Q. Okay, so you just replace X blob Q, Q blob X with X blob Q. Okay, so the next line. Yeah, Yundish, could you please tell me what rule did I use?
Associative.
Associative, yeah, perfect. And then what's the next step you wanted to do?
Replace P blob X with X blob P.
Yeah, replace P blob X with X blob P. Right. Oh, sorry, we didn't use associative. We used substitution again. Okay, we used the substitution again. So P blob X equals to X blob P. Okay, we use the substitution again. So that's a substitution. And then the final step, X blob P blob Q. Yeah, Aaron, what step did we use here?
Associative.
Associative, yeah. So you can see we start with left hand side, which is P blob Q blob X. Eventually we reach the X blob P blob Q, which is right hand side. Yeah, Aaron, what conclusion can we draw?
That P dot Q is an element of S.
Yeah, P blob Q is element of S, therefore it is,
Closed.
yeah, it's closed. Yeah. So that's how we prove closure. Okay. So this is for closure. Associative, I just did it along closure, and now we just need to find identity element, and then we need to find the inverse element. Okay. Yeah, so just do it in the next page. Yeah, so we need to prove identity, and then we need to prove inverse. Okay, so don't forget the given. Okay, so given J blob is a group, and then we're also given if A in S, A blob X must equals X blob A. And this is a if and only if statement, yeah, for all X in G. Yeah, so because J blob is a group, right? So J blob must have an identity element. So J blob must have identity element E. Okay, yeah. So E is from G, and E is identity in G. E is identity element of group G. Yeah. So all we need to prove is we're trying to prove E is also the identity element in S. Okay. So we need to prove E is also the identity element in S.
So how do you know if the two sets have the same identity element?
Whenever they have the same operations, there will be the same identity element, right? So just come back. This is just kind of a common knowledge. For example, you have real addition, quotient addition, even number addition, or complex number addition. Okay, they all forms a group. They all forms a group. Yeah. So what is the identity element for real addition? It's 0. What's the identity element for rational addition? Identity element is 0. What's the identity element for even addition? It's 0. Complex addition is 0. Why? Because anything. Okay, yeah, but that's still 0. And it is because anything plus A equals A plus 0 equals A itself. So you can see this identity element again is associated with the operation. Is associated with operation. So the same operation usually, okay, I didn't say 100%, but yeah, 99.9% the chance are the same identity element. Okay. Yeah. So if G has identity element E, we already find the identity element. Okay. So it's just E. We just need to show identity element is already in the set S. Okay, it's in the set S. So let's try this. So because identity element is element in G, okay, is element in G. So we know E operated with X equals to X operated with E equals to X for all X in G. Okay, because E is identity. Okay, E is identity. However, we also said if anything operated with X equals X operate itself, then that element is also in S. Right? Yeah. If E operated with X equals X operated with E, we can conclude E is an element in S from the definition. Okay. Definition just said if anything operated with X equals X operated with itself, it must be in the set S. So E satisfies this condition, so E must be element in S. So the identity element is in the S, so yeah, there exists a unique identity. Yeah, so we can find there's a unique identity. So this is the whole thing for identity. So the last thing we need to do is just inverse. Okay? Yeah, so inverse, we'll just say if you are given an element A in S, and then we're just trying to prove A inverse is also in S. Okay. Yeah, so if A is S, A inverse must also in the S, right? You need to prove inverse exists. Yeah, so if A is in S, okay, if A is in S, then we given A blob X must equals to X blob A for all X in G. Okay, this is given. A is element of S. Now we require to prove A inverse is also in S. Yeah, English, could you please tell us what should we show so we can show A inverse is also in S?
That A inverse blob X is equal to X blob A inverse where X is an element of G.
Yeah, so we're just trying to show A inverse blob X equals X blob A inverse. So the way is exactly the same. We start with left hand side. Okay. So start with left hand side, which is A inverse blob X. Then A inverse blob X, and this equals to A inverse blob X inverse. Right, so this is from the group properties we proved. Okay, this is from the group property. Yeah, and Dylan, do you remember which group property it is? This one is.
No.
The double inverse equals to itself. Do you remember it now? Yeah, double inverse.
I knew it was true, but like I didn't know what.
Oh, okay. Yeah. So the double inverse equals to itself. Okay. And then we need to use another property. Okay, we need to use another property. So another property we learn is X blob Y inverse equals 2. Yundish, do you remember this?
Is it Y inverse blob X inverse?
Yeah, perfect. Y inverse blob X inverse. Okay, that's another group property. Yeah, so if we just evaluate the one inside, yeah, English, could you please tell us what's A inverse blob X all inverse?
That would be X inverse blob A inverse inverse, which is just A.
Yeah, A inverse. Okay. And then A inverse, again, just using the same group properties, it just equals to A. So that's X inverse blob A inverse. Okay. X inverse blob A inverse. And then we just need to use the same group properties again. Yeah, English, could you please tell us what's X inverse A all inverse?
That would be A inverse blob X inverse inverse.
Yeah, X inverse. Cool. And double inverse just equals itself. So it's A inverse blob X, which equals to the right hand side. Okay, so we just showed A inverse blob X equals X blob A inverse.
The left hand side.
Oh, sorry.
Just show that
Yeah, wait a second. I must made a very stupid mistake. Let's just check. Where did I make the mistake?
I think you want to take the inverse of this whole thing with this.
Okay, let's try to find the mistakes first. This is X blob inverse. Oh, sorry. I think I know where I made the mistake. I made the mistake here. I evaluate this too fast. Yeah. So X blob A here equals to A blob X. Okay, X blob A equals to A blob X. Yeah, it is because the given here. Okay, given here. So the given here says as long as there's element in G, A blob that element must equal that element blob A for all blob in G. Okay, for all blob in G. And then because
In that case, can't you just use the star?
no, you can't.
Why not?
Mm,
For the same thing.
I'll think about it. I'll think about it and get back to you. But yeah, so for all x in G, because G is a group, so G have inverse element. Okay, so every single element has its own inverse. So if x is element in G, then x inverse must be an element in G. Okay, x inverse must be an element in G. So A blob x inverse must equals to x inverse blob A. Okay, and then we just replace this A blob inverse equals x inverse blob A. That's why we can switch the position of x inverse blob with A and A blob x inverse. So this line here, we used substitution. Okay, and then we just expand this again. It will just be x inverse blob A, which is x blob A inverse. Yeah, so x blob A inverse. Okay, so this finally equals to right hand side. Yeah, so we just showed A blob x equals x blob A inverse. Therefore, every element has its own inverse. Therefore, it is a group. Okay, therefore, it is a group.